This video is going to cover the pentose phosphate pathway. The pentose phosphate pathway is an alternative pathway to glycolysis. There are two phases. The first is the oxidative phase, and the second is the non-oxidative phase.
In the oxidative phase, we start with glucose 6-phosphate, which is oxidized by glucose 6-phosphate dehydrogenase, which is the catalyst. This reaction forms 6-phosphogluconolactone, and during this reaction, NADP+ is also reduced to NADPH and a positive hydrogen. In the next reaction that takes place in the oxidative phase, the 6-phosphogluconolactone is hydrolyzed by 6-phosphogluconolactonase, and it forms 6-phosphogluconate. The 6-phosphogluconate undergoes oxidative carboxylation by the 6-phosphogluconate dehydrogenase. This reaction forms ribulose 5-phosphate, which can later be used in the non-oxidative phase. It also forms NADPH and a byproduct of CO2.
Next we have the non-oxidative phase, and first we're going to go through the trans-ketolase enzyme. The first step is the thiamine pyrophosphate, which is also known as TPP, is deprotonated to form an ylide. The ylide reacts with a ketose phosphate, in this case xylulose 5-phosphate, also known as XU5P, resulting in an addition compound. The addition compound undergoes bond cleavage, releasing glyceraldehyde 3-phosphate, also known as GAP. The thiazyl ring forms a resonance-stabilized carbanion. The carbanion attacks the aldehyde carbon of the ribulose 5-phosphate produced in the oxidative phase. This produces the thiamine pyrophosphate product. The intermediate undergoes elimination reaction to yield acetoheptulose 7-phosphate, also known as S7P. The next step of the non-oxidative phase involves the transaldolase enzyme. Acetoheptulose 7-phosphate is activated by the transaldolase enzyme to form a Schiff base with a lysine, also known as an iminium ion. The protonation of the base cleaves two carbons to form dihydroxyacetone, and it releases the erythrose 4-phosphate, also known as E4P. Dihydroxyacetone, the resonance-stabilized carbanion, undergoes an aldol condensation reaction with glyceraldehyde 3-phosphate. Iminium ion undergoes hydrolysis to yield fructose 6-phosphate, also known as F6P, which is our final product.
The major products that form in the pentose phosphate pathway are fructose 6-phosphate, which can be recycled to be used either in glycolysis or again in the pentose phosphate pathway. Ribose 5-phosphate is used in DNA and RA synthesis, and NADPH is a reducing equivalent for reductive biosynthesis.
These equations show each of the steps. In oxidative phase, this is the equation. There is also the non-oxidative phase, and then below is the entire pathway, and if you need to pause the video, go right ahead. And this is our reference. So thank you for watching, and have a good day.